Hey, everyone. Welcome back. And so, once again, we're going to start off with a couple rounds of introductions. My name is Peter O'Neill. I am a cloud native architect at Web Riot, and I will let Mark introduce himself, and then Aakansha.
Thanks, Peter. So Mark Borstein, CTO, Tremolo Security.
And hey, everyone. I'm Aakansha, Developer Relations at Empathy Ops. So, yeah, nice to be here.
Awesome. And we are picking up where we left off talking with Mark before. And so today we are going to be testing Mark here to see if he can fix a cluster that I have put into a very broken state. All right, so what I have here, actually here, let me start sharing my screen. Let's swap over. Cool, so I have in my terminal here, we have a connection to a Google VM that I'm running a kind cluster on. And then I have a tunnel here that is passing into this tool called Aptitude so that we can kind of see things. And so with this visual dashboard, we can see that I'm running most of the tooling in chapter 14 of Mark's book. And so some of these deployments are not quite in the right state here. So we can see that we're having some troubles with these NIP.io connections. And so if you guys remember from last time, we were using NIP.io in order to have a DNS address so that we can actually use certificates. And so these clusters are, the kind cluster here is deploying these containers and trying to authenticate using these URLs and the certificates that are loaded onto the cluster. So Mark, what do you think we should do first to troubleshoot this?
Okay, so first off, I'm going to report you to David, our friend Rockcode, for stealing his cluster D show, bringing me on to fix a broken cluster. Okay, so it looks like, all right, our root cause is going to be the AMQ orchestra pod. So chapter 14. So when you say the book, this is what you're talking about: Kubernetes and Enterprise, second edition. And in the last chapter of the book, what we did was we built out a multi-tenant implementation. The idea behind that was that we wanted to create a kind of a, today we call it platform engineering. And in fact, when we're in the process of revamping this book, it's going to be out in August. We're actually renaming that we're splitting that chapter into two and calling one part, how you build out your pipelines. And the second part will be actually about platform engineering and building a self-service platform for your developers. So the idea behind the chapter is we roll out GitLab, we roll out for source code management, we roll out Tecton CD for CICD pipelines. We roll out, what else do we roll out? Argo CD for GitOps. And then we're using Open Unison to orchestrate everything. So the big thing that is different about this than the previous implementations, before we were using Open Unison as an SSO platform, right? We're using it for authentication to get into our cluster. But now what we're doing is we're going to say, okay, in addition to using Open Unison for managing our cluster or for managing access to our cluster, we're actually going to use Open Unison as kind of our bootstrap to get environments up and running. So it's not trying to replace a infrastructure as code tool like Terraform or Pulumi, but rather build out that initial environment and provide a workflow for doing that. And the reason why Open Unison is pretty good at that is because all these different systems have their own sense of identity, right? GitLab has its own sense of identity. Argo has its own sense of identity. Kubernetes has its own sense of identity. And so in order to make all these things work together, you have to know how those identity systems all work together. So that being said, when we run Open Unison as a namespace as a service platform, what we're actually doing is we need to deploy a couple of different components in addition to it. One of them is a message bus. That's how we handle reliability and high availability. And if you don't have one, we bundle ActiveMQ, popular open source message bus system. So that's the thing that's broken right now.
Gotcha. And clarifying question here real quick. And so you used the word environment a number of times there, and I just want to kind of like clarify what that means exactly. And from what you said, it sounds like when you say environment, this is just like all the components necessary for the pieces to talk together. So not necessarily the infrastructure, but just how the piping works between all the tooling. Is that correct?
To a degree. So the system that we designed in the chapter, the assumptions that we made were, you were going to have a development environment, a dev namespace. Now we did everything in one cluster to try and keep it running on one cluster. So you know, in production, you wouldn't have a dev namespace and a prod namespace. You'd have a dev cluster and a prod cluster, right? So, but we assume you're going to have a dev namespace and a prod namespace. That's the Kubernetes side. Then you're going to need a pipeline namespace, right? Because Tekton CD, if you're not familiar with Tekton, it's a pipeline system built on top of Kubernetes native objects. So instead of having some kind of external runner, it's firing up pods inside of your cluster to do your builds. So you need you need a namespace for your pipelines. But then you also need, think about the different systems that are involved. Your source code gets stored in something. Maybe it's GitHub. In this case, we're using GitLab, which means in GitLab, you need to have a space where the developers who are authorized to access that code are allowed to get in there, which means you have to provision that inside of GitLab. You also have to provision some way to map from your enterprise identity, in this case, our Active Directory pod, into GitLab and into managing that. But think about the GitOps workflow. You're not going to log into Kubernetes and make a change to a deployment, right? You're going to make some change to code, merge that into a branch, and then have your pipeline kick off from that branch.
Yeah, and
Who's
actually,
response?
let me pause you there for a second, because like I feel like there's sometimes like I hear people get confused quite a bit between like GitOps and pipelines, because some people think like, oh, if you're doing pipelines correctly, you're only doing GitOps. But I've seen people deploy pipelines in many different ways, and so maybe you can explain a little bit about like why pipelines and like just the GitOps mindset work so well together.
Yeah, so you know, a pipeline is not anything super special, right? It's running code, right? Like that's all a pipeline is. It's a series of steps that are usually assembled from some smaller pieces. So think about, you know, the plumbing of a pipe that's made up of different smaller pipes in order to do something. And that something is usually some variance of get source code, build it into an artifact of some kind, push it into an artifact repository, and then tell some system, hey, go look at this new artifact, right? Like that's how conceptually from 100,000 feet, every pipeline works. So there are really two ways you can look at that last piece. The how do you tell a system go look at that new artifact? One way is to call the API, right? Like you can send a JSON patch over to a Kubernetes deployment with a new container tag and say, hey, go get this thing. But now the problem with that is that where's the record of that happening, right? Like where is the decision that was made to do that? How do you roll that back? Where's the record of what the old version was in order to make sure that if there's a problem, you can roll back, or as is called in the GitOps world, often roll forward, where you're not really rolling back the change, you're just changing the change to go back. So where GitOps would then come in and say, okay, we're using Git as our source of truth, right? That's our record of what changes are being made to the environment. That's our CR system, right? That's our control management system, is Git. But our pipeline now has to update Git. So instead of saying, okay, my pipeline is going to run a patch against a deployment running inside of Kubernetes, it says I need to get the code for my manifests. I need to run a local patch, right? Like it's that same patch on that deployment, but instead of that patch being an API call, that patch goes into Git. Enough information goes into the commit to tie it back to the pipeline run, and then you push it back into Git. So at that point, it's in Git. Now you need something to say, oh, wait, this has changed, right? So that's where something like Argo comes in, or Flux, where Argo says, oh, this deployment's changed. We need to reconcile it to make sure it stays on track. So now, instead of an admin running a build, running a push, making a change to a deployment, and writing everything down somewhere, you now have this automation that encapsulates both your change management and the operations of making the change.
Right, and this automation is the part where things get spicy, right? Because this is where you've now granted so much authentication pieces between all the automation, and this is where people stop seeing like, oh, where's the boundary between one tool and another, because they all have access to each other, and this is where Open Unison is coming in to kind of take over and build some of that protection, correct?
Exactly. So as an example, so you're a developer, right? You're writing your code, you get it working locally, you want to push it into the common dev environment. You're going to submit a PR, right? Or the equivalent of a PR in GitLab. Somebody has to approve that, which means somebody has to be authorized to approve it, right? That's an identity decision, because GitLab has a mechanism for doing that. Once it gets authorized, you want to make sure that there's a trail somewhere of who authorized it. And so you want to be able to tie it back. So let's say Aakansha is our manager. She's responsible for approving the PR. She approves it. Why is Aakansha in that role? Who said Aakansha is the person responsible for this approval, right? That's an identity issue. That's an identity question. Aakansha gets a great new job. She's going on to bigger, better things. She leaves us behind, and a new person comes in. Well, how do we make sure that Aakansha no longer has access to this, especially in a SaaS world where maybe we're using a hosted GitHub or GitLab, where Aakansha's credentials might still be valid, right? Like, these are all identity questions. And then the other thing that comes up from an identity standpoint, and this is one where GitOps often kind of falls apart a little, is you're no longer talking directly to your API server. So all those beautifully crafted RBAC rules that you've created to make sure that only people who have access to their namespaces can make changes to go out the window, because Argo CD uses cluster admin, unless you're deploying like an Argo per namespace, which is a whole other mess of issues. So you can check in, for instance, a resource quota into your namespace Git, and if you don't have the right rules in place in Argo, even though you as a namespace owner do not have the right to change resource quotas, because resource quotas affect the entire cluster. So even though they're scoped at a namespace, the admin cluster role does not give you access to that in standard Kubernetes. But you bypass that by checking it in to a Git repository. So you got to now use Argo's own policies to make sure that you're not able to override that. So that's still an identity question.
Right. And so with each of these tools having their own authentication mechanisms, is this what we're trying to solve now? Is that we have this identity piece that is shared between those toolings, so that you know what that one identity is scoped to between each tool in your tech stack? Is that what we're trying to do here?
So it's the authentication is actually the easy part. It's the authorization that's super hard, because each one has its own definition of identity. So as an example, when I say the word group, what I typically think of is a list of people, right? Like I, as a user, am a member of a group. That group, anybody in this group is authorized to be an admin in this namespace, as an example. But that's different from GitLab. GitLab is very different in the way it approaches groups. A group in GitLab has more to do with the way the repositories are built and the entitlements for different roles in that repository. So you don't create a group and then associate that group with a set of permissions. The group is based on the repository that you're in, and each repository then has different collection sets of authorizations based on that. So you have managers, you have approvers in GitLab, you have developers, but those aren't, like, you can't create a separate group for that. You know, if we go over to GitHub as an example, they have teams, right? That's a different mechanism to be able to manage. So even though they all kind of rhyme and they call kind of, you know, everything tastes like chicken, it ain't chicken, right? You know, different spices, different flavors, right? Even though it all kind of tastes like chicken. So
and do you think that's because, like, I feel like RBAC was one of the easier things that was implemented in the beginning, and then all these different tools like absorbed RBAC and started to just like modify it in their own way? Is that why all these things taste like chicken?
No, I think that, so RBAC, even RBAC and the concept of, like, I just published a blog post today on EKS identity. And I spent like the first half of it comparing what AWS's definition of a role is and what Kubernetes' definition of a role is. And they're not the same thing.
Oh, yeah, no, I remember EKS very well, because the whole like conversion from IAM into the RBAC roles inside the cluster, huge pain in the ass, even just to like figure out where the thing broke down. And you're just like, oh, let me dig through the configs on the AWS side. Let me look inside the cluster. Did my token actually convert from the AWS CLI? And you're just like, oh my God, there's so many steps there. And you just don't really know at what point did it break.
Right. And part of what makes that so hard is, you know, think of the definition, the two systems' different definitions of a role, right? They're very close, but they're very different. A Kubernetes role is a collection of APIs that somebody can have access to. It's really a permission set, right? The role says, if you're allowed to do this thing, here's all the APIs and the actions that you can do against them. But it doesn't mean anything about the who, it's just the what, right? Whereas in AWS, a role is literally just the who, right? It's who is associated with this thing, and it's a placeholder that you then attach permissions to. So a role in AWS is closer to a role binding in Kubernetes. Mm-hmm. They both taste like chicken, but they use different sauces. You know, and so back in my consulting days, you know, there was a major manufacturer where we were told on our first day, if you use the term RBAC, and this had nothing to do with Kubernetes, this is just straight up identity consulting. If you use the term RBAC, today is your last day. You will not use that term in any meeting at this customer, because they have had such terrible, you know, such a bad taste in their mouths. It wasn't good chicken. And yes, I'm going to beat this metaphor to death, unfortunately. So what makes it so hard is that authentication is a pretty mechanical process. Who are you, right? It's a token. It's a password. It's a verifiable credential. It's something, right? But it's who are you? Authorization is business logic. It's not as mechanical, right? You're making a decision based on the reason why you're implementing the thing. So you have to understand what that thing is. So the fact that GitHub and GitLab have very different approaches to identity isn't because one is right or wrong, but it's because they know their systems best. They know how this is supposed to fit together. And when we've built these Rube Goldberg machines in the world of all these different systems that work together, that's the hard part, is figuring out how these different pieces fit. So like GitLab will say, well, use a monolith, right? GitLab does everything for you. It'll do your CICD. It'll do your authorization. It'll do, I don't think they're doing GitOps yet, but I wouldn't be surprised if they did at some point. And so that's one way to simplify it. The other way is to have a tool that knows how to talk to all these different things and amalgamate them and figure out how to normalize it into this cross-business logic. And that's where Open Unison comes in.
Right. And so like let's tie this back now, kind of wrap this up with a bow. We're talking about pipeline security specifically, right? So then how do we, you said you're like, make the right decisions here for authorization? How do we identify and give that identity to the pipeline and make the right authorization decisions? Like, how do we conceptually start to think about that when we have all these different components plugged in?
So you got to start with a blank piece of paper and just be like, what are we trying to accomplish here, right? It's the joke, what's every senior developer's response? It depends. You got to start with, what are you trying to accomplish? What do you ultimately want your pipelines to do? Then you've got to figure out, what do you have to use, right? So if, especially in an enterprise, the focus of the book is on enterprise, and in enterprise, it's all about silos, right? Where are the silos? Where are the management silos? And how is that going to impact your technology? As an example, if you're told you're going to use GitLab, it doesn't matter how much you like Gitea, right? Or GitHub or something else. The enterprise bought GitLab, you're going to use GitLab, right? Secrets management, right? If there's a centralized vault, it doesn't matter what you want to use, you're going to use that. And if you don't use that, bad things are going to happen, right? Like, you might get away with it today, but down the line, you're going to run into those problems. So you got to figure out what tools you have to use. Then you have to figure out, from a security standpoint, what are the implications of security for each of those? So, GitLab, what's the security implication of using GitLab? Well, they require personal access tokens, right? They don't have any kind of short-lived mechanism for identity. Same with Argo. Kubernetes does, so that's good, right? What about certificate management, right? Argo and GitHub and all these different things, they're going to talk to Git repositories. Are they going to use tokens? Are they going to use SSH keys? How do you want to handle that? So there's that aspect of it. Then you want to figure out who has access to these different components and where. So Argo, as an example, has its own policy language. What does that look like? How do you map that in? GitLab has its own framework entirely. It's completely different than most other identities. So it isn't rocket science. You just have to work through each different component and how they fit together. So in this lab, like, one of the most challenging things we had was GitLab kind of assumes it's going to be the source of truth for authentication. So if you don't use GitLab to authenticate everything, it's actually kind of difficult to externalize the authorization process.
And by source of truth, you mean that the identity tokens originate from GitLab and then get pushed into the other services?
Right. So if you use GitLab to SSO into Kubernetes and into Argo and into the different components in your pipeline, it's a little bit easier. But if your group, let's say you're using Active Directory to store your groups, as an example, or any external system to store your groups, and you go to log in to GitLab, well, now you need to map from those groups into GitLab's sense of groups. And it's not just the group name here and the group name there. It's a group plus what level of entitlements do you want to have attached to it. So there's more intelligence that has to go into that than a simple one-to-one mapping. So like when we wrote the lab, when you log into GitLab, we do a just-in-time sync of your permissions into GitLab before we complete the SSO process. Because Open Unison is your source of truth for authorization for everything. Because that's where we store all the group information. So it's just a lot of different moving parts that you just need to be aware of. So that's why a lot of times with pipeline security, the easiest thing is I'll just add a token as a secret and call it an afternoon. Whereas like, we talked about in the Twitter space last week, that's like the worst way to do it, because now you're just waiting for somebody to misappropriate that token and do something bad with it. And there's nothing you can do about it.
Yeah.
So like in this lab, we will be,
No, go ahead.
Yeah, so like in this lab, we will be using Tecton, right, to create the CI/CD pipeline.
Well, so Tecton is the pipeline. So Tecton, Tecton was born out of the Knative project. Knative was the first kind of Kubernetes, or I guess I would call it CNCF, because I don't want to call it Kubernetes native, because OpenFAS probably wins that prize. But the first CNCF pipe or serverless system, right? Like it was that first CNCF project that was, you take code, you upload it to something, and boom, you have a running service. And one of the components of that was a pipeline that said, okay, how do we go from this code that somebody is uploading to a container to eventually a pod? So they broke that out into its own project called Tecton CD. And so that is a Kubernetes native way of building pipelines. That looks fairly close to GitHub Actions, GitLab. They all work under basically the exact same principles. But Tecton is more Kubernetes native, where it runs on Kubernetes. It uses webhooks for its automatic triggering. Everything runs inside of a pod. So that's where Tecton comes into the picture.
Got it. And because Tecton runs on Kubernetes like everything else, does that mean that the flavors of chicken start to taste more the same because they're all living in the same environment?
More like different flavors of wings. So
they look conceptually very the same, but one could be real spicy and one might be like just barbecue.
Exactly. So Tecton, and we're actually removing Tecton in the latest version of the book, just because it doesn't seem to have gotten the adoption that really thought it would be in Kubernetes native. One of the things that is conceptually great about Tecton that probably makes the implementation harder is because it is built on Kubernetes. Think about what's easy with Kubernetes: stateless. What's hard with Kubernetes? State. Where are you going to get your state from? And when you move between tasks in a pipeline, there's often different levels of state, right? You're generating artifacts. You are generating tags and data that you want to hold on to for later stages. Where are you going to store that? Well, in a Kubernetes native way, you need to create a persistent volume to put that data on. What's going to be your persistent, like, where are you storing it? How are you going to manage how much of it gets provisioned? How are you going to, what does that look like? And so if you've got a really mature Kubernetes environment, that's not terribly difficult to do. But if it's a less mature Kubernetes environment, that state is difficult to manage in a highly available way. Something like a tech, or something like GitHub or GitLab or Jenkins or Circle. I'm not endorsing anything in particular, but making that part someone else's problem becomes a lot nicer of an idea once you realize, I've got to manage all of these different moving pieces. Because you're looking at how the chicken sausage gets made, right? Sticking with the same bird, or food source. So I think Tecton has lost a lot of momentum because there just hasn't been a lot of great automation, and it's still in development. It's a lot of things have changed. They've simplified a lot of things, but it never got
what's taking
the
its place
momentum.
then? Are people just moving away from trying to run their own pipeline service and just adopting the tools that are out there? Like every cloud has a thing, every Git provider has a thing, and so are people just going towards cloud solutions, or like what else is in that like self-hosted realm?
Most of what I see is some combination of like most of the hosted stuff is going to be either a domain specific tool like Circle CI as an example, or any of the like hosted, like all they do is pipelines, or going straight to your Git service like GitHub or GitLab. Like that's what we ended up doing. We're doing in the third edition of the books. We're saying, all right, we're using GitLab. We're just going to use GitLab for the pipeline. We're not really gaining a lot of value out of using Tecton for the pipelining system when we already have GitLab.
Yeah, and if your pipeline is fairly simple, then it's kind of like why add the complexity of another tool, right? That's why like GitHub Actions for me is like my just go-to for 90% of what I do, because it covers most use cases. And so it's just like it just makes it just so simple that it's just like I just drop a YAML file into my repo that already exists, and it just knows what to do with it.
Exactly. And like Tremolo, all of our production builds are done using GitHub Actions. You know, and then you've got the folks that still run Jenkins at scale, which is bonkerballs to me sometimes, but they do it. And so, you know, I feel like Tecton is kind of like too complicated or you know, too much for the use cases that are simpler. But
so what is that dividing point? At what point do you say like, okay, GitHub Actions or like the GitLab pipeline stuff is just too simple and you want to expand out of it? Like what are those barriers that you see people hitting that they're like, okay, I need a more mature pipeline tool?
I mean, I don't know that it's a matter of maturity because they all do basically the same thing, right? Like at the end of the day, you're executing code. You know, where I see the pipelining systems differing is like if I'm storing all my code in GitHub, I'm just going to use GitHub, right? Like if I'm storing all my code in GitLab, I'm probably just going to use GitLab unless I've already got a mature system in place. You know, I've never seen a great value proposition for why you should use the third party, you know, hosted Git run or pipeline runners, right? You know, like Tremolo internally, we use actions for most things, but like when we do some stuff that is very specific to our AWS implementation, we actually use code build because code build has tight integration with AWS. So those artifacts, those containers can go directly into an ECR registry and then update EKS without having a service account token anywhere. Right? Now, in theory, I could do that now with GitHub. I've just been lazy and we just never updated it. But I could move that code into GitHub now because GitHub now has that tight integration with AWS as well, where I don't need to store an AWS key in GitHub secrets anymore. So I think it's more about the developer workflow and the integrations rather than a maturity level. Yeah, it's more about what integrates, what's the path of least resistance to getting into prod versus this particular system is just too kludgy for me. It's like I've got customers that I manage clusters for them that are in Azure, and we use Azure DevOps. Now I curse it every day, and I have no problem saying that on the internet. And I have friends at Microsoft that yes, offense, because of the years of my life you've taken away from me. But you know, other than really specific implementation detail, whatever gets you into the systems you're working on the fastest, that's what you should go with.
Got it. And then, so when looking at each of these tooling, you've seen more or less the same security tooling and parameters inside of each of these pipeline providers, or do some of them
I wouldn't
lack
go
more than
that
others?
far. So GitHub, I would say, is the most mature. Like GitHub,
As far as security goes, you mean?
as far as security goes, especially around identity. And the reason why I say that is that when you generate a GitHub token to use with an external service, like say with AWS, GitHub actually provides a way to do that out of the box that is the right way to do it based on the standard. So when you get a token inside of GitHub, and I forget what the environment variable is off the top of my head, there's an issuer and there's an audience. The audience that you get issued is for GitHub because you're only supposed to be using it for GitHub services. So you're going to use it to talk to the GitHub API for something. If you want to use that to go talk to AWS, you exchange it for a token specifically for AWS. So like I wrote a GitHub action to make that easier for people. And we, it's boilerplate code that we use that just says, okay, GitHub, give me a token with this audience. And the audience is like, was it signin.aws.com, whatever the AWS IDP is. So you're doing that proper step of exchanging tokens so that you have a properly scoped token to use with another system. GitLab doesn't do that. GitLab, you get given a token, it's scoped to the GitLab APIs, but if you want to use it with something else, you just ignore the audience. Mm-hmm. So now if somebody, you're not able to limit that blast radius if somebody loses that token, even though it's a short-lived token, so there's some mitigation in there. There's no way to mitigate that blast radius. I think Circle CI does that too, the last time I looked. So, whereas Tekton would be another example where Tekton, you get a Kubernetes service account. So you could either use the Kubernetes, like you can use the token request API to mount a token specific for AWS. You could use that, but that would mean AWS would need to trust your cluster's issuer, which kind of gets a little weird from a security standpoint. Not entirely sure you want to do that. Or you could use a token exchange service. So like you could say, hey, Open Unison, I have a token for this, give me a token for that. So you could go that approach as well.
And how does the token exchange validate both sides? You just need an identity on both sides that's trusted by the exchanger. Is that how that works?
Basically, so when you do a token exchange, you've got an identity provider, usually the issuer of the token. It doesn't have to be, a little bit of debate there, but it's usually the issuer of the token. And you tell the identity provider, you're going to become a security token service, is the standard name for it. And I'm going to tell you, I want a token for GitHub using my current token. So you have to authenticate the existing token, right? That current token needs to still be valid. You need to authorize the requester to say, hey, are you even allowed to have a token for this? Like as Mark, I have a token, I'm the Mark pipeline. The Mark pipeline wants a token for GitHub or for AWS. Is that allowed? Like who authorized that? What policy says that that's allowed? You also want to authorize the situation because, back to the beginning of our conversation, we were talking about that different identity systems are very different. Systems are very different, right? GitLab has a totally different concept of identity from AWS. Kubernetes has a different concept of AWS. So you're generally not just creating the token, you're also providing authorization context in the form of claims.
And so if I was to make like a metaphor about this, if I was to make a metaphor about this, so we can say like the token exchanger is kind of like a crossing guard. And anytime any one of these tools wants to cross over the street and go from one tool to another, they'll have to ask this token exchanger, which acts as that like guard or barrier between the two things, so that each one isn't just directly connected, and they can just go to any side that they want without any questions. Is that more or less correct?
Yes, except the crossing guard has a list that says who can go where.
Mm-hmm.
And as you're crossing the street, you also have to change clothes.
Mm-hmm.
So the police officer crossing the street might change police uniforms, but can't put on a firefighter uniform. Because you've got to, because think about it this way, right? Kubernetes, so let's go back to AWS, okay? AWS has a difference. AWS, when it accepts a token, you have a set of conditions that look at claims to be able to authorize what the assumed role can do inside of AWS with the token. GitLab doesn't have that, right? GitLab, you've got a membership of groups. So in order for me to get a token to AWS in a way that lines up with what AWS is expecting, there's a transformation that happens there. And you need to make sure to authorize that transformation is allowed to occur. There's a big difference between a municipality police form or police uniform and a state's police uniform, an FBI uniform, right? Those get you different things. They're not just police uniforms. So you've got to make sure that when you change that token, that's an authorized thing to do. Because again, it's a token, it's a bearer token. Once it's out in the wild, that's it.
Right. So it's just like you don't want them to cross the street and then all of a sudden they're like the principal of the school now, and they can do whatever they want inside of the school instead of the substitute teacher.
Exactly.
Mm-hmm.
You also
so
have
like I'm trying to.
Go ahead, Aakansha.
Oh, yeah, you please complete, then I will ask my question, because I'm trying to understand the whole workflow. So I wanted to make sure that I'm understanding it correctly. So like first we have the GitLab where we are having the code base. Then we introduce Tecton to build which is the CICD pipeline, right? And then we move to the GitOps approach, and we are using Argo CD to implement that model. And then we are introducing Open Unison, which is like accessing, automating, and like authenticating the whole process, right?
Yep.
And where does like the gatekeeper, like the Okta thing, comes into the picture? Like, is it after Open Unison has done the workflow?
So that's a great question. So like your gatekeeper, your Okta, is at kind of the front, right? Like it's validating who you are. It might store your permissions, like your groups, maybe attributes. But at that point, it's done. Because Argo CD doesn't know how to talk to Okta. Tecton doesn't know how to talk to Okta. GitLab doesn't know how to talk to Okta. I mean, it might know how to talk to Okta from an SSO perspective. But it doesn't know how to query Okta for different information, right? It's whatever gets jammed into that token can then be mapped into different things. So none of these things know how to talk to Okta, which is where Open Unison comes in. We know how to talk to all these different things, and we know how to talk to Okta, or we know how to talk to Active Directory or GitHub or whatever your authentication source is. So when you're talking about where these pieces all fit, they all kind of talk to each other, and Open Unison talks to them, but they don't talk directly to Okta because they don't know how.
Okay. So like Open Unison does it for them, like talking to the Okta?
Yep. So what happens is Open Unison says, okay. So Open Unison says, you access Open Unison. Open Unison authenticates you to Okta, right? So now Open Unison, from a security standpoint, is holding the keys to all the kingdoms. Everybody trusts Open Unison. Open Unison trusts Okta, right? So if you think about the new person who shows up to the party, right? Everybody knows that one person who knows everybody. That's Open Unison. Everybody knows Open Unison, and Open Unison knows everybody. So if Open Unison says they're cool, they're cool. So that's where that really comes in, is because these systems all are built in a vacuum, right? Like Argo CD is built in a vacuum. Its focus is GitOps. GitLab is kind of built in a vacuum. Its focus is development environments. They're not identity tools. And that's where Open Unison comes in, is to be able to bridge those different identities.
Got it. And also, like, I read in a couple of blogs that enterprise security uses self-signed certificates. So, like, why that is preferred?
It depends on the context. Like most enterprises will have so when people say self-signed certificate, what they generally mean is I generated a certificate locally and I'm just going to trust it and use it. What most enterprises do is they have an internal certificate authority. So, your browser launches, there's a big trust store of, a couple of hundred CAs. They're trusted by default. Well, most enterprises are not going to go to those CAs to get certificates on a day-to-day basis. They're going to say, either a cost thing, right? Like, why are you going to pay DigiCert for some internal thing that nobody's ever going to access in the real world, in the outside world? But there's also a security thing, right? Like even Let's Encrypt. You're not going to go to Let's Encrypt for all your internal certs, right? That you don't want Let's Encrypt having a public record of every server you have inside of your environment. Like, I'm not a fan of security through obscurity, but it doesn't mean I post it out on the web either. And so you'll have an internal CA. That internal CA will be responsible for issuing certificates. And so what most enterprises will do is they'll say, have that internal CA. The internal CA will then have a process by which they issue certificates. If there are some compliance rules in place, which there generally are, there's usually a book that's like, that big of different compliance rules, even though you can write a CA with a couple of open SSL commands. And so that then becomes kind of an issue of how do you get those certs? Then the question becomes something like Kubernetes, where you not only have your enterprise CA certificate, but everything running inside the cluster needs certificates. So what we did in the chapter, and we kind of did this before in previous live streams, where we rolled out Cert Manager. We said, okay, here's our CA certificate, and we're going to have everything get issued off of that. And that's usually okay from a compliance standpoint because it's all internal. It's not leaving the cluster. There's always been this argument that Venafi and other CAs have made in the cloud native world that says, hey, instead of using a self-signed CA certificate, I should get what's called an intermediary certificate from the enterprise CA. So that way I can issue CA certificates that are trusted by the enterprise CA. Problem there becomes that big giant stack of compliance rules goes out the window. And so they say, no, we're not going to do that. So typically what happens is you'll have a ingress certificate signed, often a wildcard signed by the enterprise CA, but then all the intercluster communications will happen from an internal, like a cert manager signed CA.
Nice. And so we're running close on time. We're a little over 5 minutes left. Do you want to wrap us up here and kind of give us your top 3 things to look out for when configuring security for your pipelines?
Yeah, I mean, identity is the first one. What identity is it using? What identity is it able to go with? are you getting short-lived tokens? Can you reuse that identity to talk to different systems? That's going to be the first question. The second question is then going to be, can the systems I need to interact with consume that identity? What does that look like? And then what kind of secrets management are there, right? Like, am I using an internal secrets management system? Am I using an external secrets management system, which can piggyback off of that identity? So like, can I use that identity to talk to Vault to get secrets, as an example? And then everything else kind of builds out from there from a security standpoint. Then you get into the different layers, right? Well, is it running on a secured node? Is it, the system itself secured? Short-lived tokens are kind of stupid if I can just use admin password to log in, get access to the private key, and then boop, issue whatever tokens I want. So it's, then you dive into that side of things.
Cool. Awesome. This sounds pretty good. So it's identity, security, and then kind of just like identity, secrets, and then kind of just more practical security components that are just like the baseline of like, don't leave generic passwords in a wiki for your nodes to get in the back end.
Exactly.
Nice. All right. That sounds good. So last few minutes here, Aakansha, do you have any closing comments for us?
No. I think we discussed a lot around pipelines and how does Argo CD, Tecton, or GitLab, everything falls into the picture. And of course, how openness is the great product to do everything for us. So yeah, that was a nice discussion.
Nice. Awesome. Well, I think this has been very informative for me. Lots of interesting pieces for me to go back and play with. Any closing comments for you, Mark?
Just check out the book. And then we're going to have the new edition coming out in August, I believe.
August. Nice.
Yeah.
And so hopefully we'll have you on at some point to talk about the new book and how much of that tech stack has changed between edition 1 and edition 2, which I think was 3 years apart?
It'll be about, I think it might be closer to 4. One of the last book came out in 2021. So yeah, it'll be almost 3 full years between.
And that's editions. And your entire tech stack can completely change in 3 years. Like you can really, it's funny looking at just like the release cycle in Kubernetes and you're just like, oh, okay. So every 4 months now, basically things are changing to some decent degree. And just like, if you don't do anything for a year, you're like, oh, I'm very out of date.
Yeah, exactly.
Cool. All right, then. Let's wrap it up then. This was good talking to everybody. And we'll see everyone on the next stream.
Thanks, everyone. Bye.
Bye.